So, all the incredible AI that's everywhere now? We're talking chatbots, image generators, even major scientific breakthroughs. What if I told you that pretty much all of it, yeah, all of it, traces back to a single 8-page research paper that came out just a few years ago? It sounds kind of crazy, I know, but it's absolutely true. And I mean, this is not just any paper. Check out this number. It's been cited over 173,000 times. To give you some perspective on that, that single number makes it one of the most influential academic papers of the entire 21st century. And remember, it was only published back in 2017. So what is this paper? It's called Attention is All You Need, and it was written by 8 researchers over at Google. And yeah, if you're a music fan, that title probably sounds familiar. It's a direct nod to the Beatles song All You Need Is Love. It's kind of a fun, playful title for a paper that was, well, about to change absolutely everything. Okay, so to really understand why this paper was such a game changer, we have to rewind a little bit and look at the problem they were trying to solve. And it all boils down to how computers used to understand language, one word at a time. For years and years, the standard way for an AI to process a sentence was to read it just like you or I would. You start at the first word, then the second, then the third, and so on. A perfectly straight line from beginning to end. And the tech behind this was called a recurrent neural network, or RNN for short. You might also hear about its souped-up cousin, the LSTM. But the core idea for both was really simple. The model reads word number 1, thinks about it, and then passes a little memory of that word on to word number 2. It's like a chain, where each link passes information to the next. The problem was, this whole approach created a massive bottleneck. First off, it was just plain slow. I mean, the model literally couldn't start on the second word until it was totally done with the first. And on top of that, they were forgetful. By the time an RNN got to the end of a long paragraph, it had pretty much forgotten what the beginning was about. It's a famous issue called the vanishing gradient problem. But the real killer, you couldn't just throw more computer power at it to make it faster. It was stuck in that single file line, and that was that. And this is where everything starts to change. The Google researchers came along with a radical idea, one that grew out of an older concept that was just starting to get some traction, called attention. Now, this idea didn't just appear out of thin air. RNNs had been the gold standard since the 90s. Then, around 2014, people started tacking on something called an attention mechanism to these old models. It was a neat trick that helped them focus on the most important words. But in 2017, this paper took a colossal leap. One of the authors had this hunch. What if we just got rid of the slow, sequential part altogether? What if we only used attention? The title of their paper wasn't just a clever name. It was their whole hypothesis. Attention is all you need. And that led them to the big question, the one that broke everything wide open. What if a model didn't have to read in a straight line? What if it could look at the entire sentence, all at once, and in a single instant, figure out how every single word relates to every other word? That right there was the breakthrough. So let's just put that side by side. The old way with RNNs was slow, one by one, and it would forget things. This new architecture, which they named the transformer, processed everything at the same time. It was amazing at seeing connections across really long sentences, and this is the most important part, it was built from the ground up to be parallelized. For the first time, you could throw thousands of GPUs at a language problem and train these things at a scale and speed that was just unimaginable before. Okay, so how on earth does this actually work? Let's peek under the hood of the transformer. Don't worry, we're going to skip all the heavy math and just focus on the 3 big, clever ideas that make the whole thing tick. All right, it all boils down to these 3 key ingredients. First, you've got self-attention. That's the main engine. Then there's multi-head attention, which is like giving that engine multiple points of view. And finally, positional encoding, which is a really smart hack for keeping track of the word order. First up, self-attention. This is the heart of the whole thing. Imagine it this way. For every single word in a sentence, the model basically shouts out a question, a query, like, "Hey everyone, how relevant are you to me?" Then every other word holds up its key, which is kind of like its identity, saying, "Here's what I'm about." The model looks at all the keys, sees which ones match its query best, and then grabs the value or the meaning from those most important words. And the magic is, it does this for every single word all at the exact same time, building this incredibly rich map of how the whole sentence fits together. But it gets even cooler than that. The model doesn't just ask that question from one perspective. That's where multi-head attention comes in.
It runs that whole self-attention process many times, all in parallel, and each head is looking for something different. So one head might be focused on grammar, like which word is the verb. Another head might be looking at the semantic meaning, like who did what to whom. It's basically like having a whole committee of experts all analyzing the sentence simultaneously, each with their own specialty.
Okay, but hold on. If you're looking at all the words at once, how does the model know their order, right? The dog bit the man means something totally different from the man bit the dog. They came up with a brilliant solution for this called positional encoding. Basically, before they process anything, they add a little piece of data, think of it like a unique GPS coordinate, to each word. This coordinate tells the model exactly where that word is in the sequence, first, second, third, and so on. So it gets all the benefits of parallel processing without losing that crucial sense of order. So you put those three things together, self-attention, multi-head attention, and positional encoding, and you get the transformer. And that architecture, right there, is the engine that kicked off the modern AI boom that we are all living through right now.
So why was this such a seismic shift? It all came down to one word: parallelization. That was the key. By finally breaking out of that slow, one word at a time line, researchers could now train absolutely enormous models on unbelievable amounts of data. It meant you could finally scale AI in a way that was just a pipe dream before. And look, this table from the original paper really tells the whole story. The big transformer model they built didn't just match the best models at the time, it beat them. But check out the training time, just 3.5 days. The other models took weeks to train. So it wasn't just that the transformer was better, it was that it was drastically faster and more efficient to train. And that meant the entire field of AI research was about to hit the accelerator hard. And you can see the results of that acceleration all around you. This transformer architecture, it's the literal backbone of pretty much every major AI system you use or hear about. We're talking ChatGPT, Gemini, the technology that powers Google Search, even the crazy image and video generators like DALL-E and Sora. It's even revolutionizing science with tools like AlphaFold for protein folding. Seriously, it is everywhere.
And here's maybe the most telling detail of all. As a final testament to just how huge this paper was, every single one of those 8 authors has since left Google. And what did they do? They went off and founded their own AI companies, many of which are now incredibly successful. They saw the writing on the wall. They knew they had just created something that would change the world.
Which kind of brings us full circle and leaves us with this one big question. The transformer came from this simple, almost poetic, but incredibly powerful idea that when it comes to understanding language, attention is all you need. That single idea completely reshaped our world. So, if attention was the breakthrough that unlocked the AI of today, what's the next fundamental idea that's out there, just waiting to be discovered?